Hello and welcome back. We are going to be working in lesson 5.5 today, and it's all about graphing, the beginnings of our graphing of the trig function. So we're going to start with the sine and the cosine function and kind of get familiar with them and some different pieces about them. So first off, we're going to look at the sine function, and we have a table here on page 455 in the book that gives you the different base values in radians of sine, and then the evaluated value of that of sine. So 0, pi over 4, pi over 2, 3 pi over 4, pi. Pi over 4, remember, is a 45-degree angle. Pi over 2 is a 90-degree. 3 pi over 4 is 135, and then pi is 180, and it kind of goes from there. So at these spots, sine starts at 0, and then it works its way up to 1 at pi over 2, or 90 degrees, and it goes back down to 0 at pi, and then it's a -1 at 3 pi over 2, and then it's back to 0 again at 2 pi. So that is the main graph of sine. Okay. So if we look at cosine down on table 2, table 2, we have the same t values. And then when we look at cosine, we remember that cosine starts at 1 and actually decreases to 0 at pi over 2, or 90 degrees. And then is -1 at pi, goes back to 0 at 270, and then back to 1 at 2 pi. So they're oscillating just the opposite of each other. Okay. So these functions, all of our trig functions, are called periodic functions because they kind of make a circular fashion. If you were to take this here and then, so from 0 to pi, where my mouse is, and then if you were to grab this 2 pi and wrap it around, it would make a circle. So that's kind of where we see it's oscillating kind of like water, where it goes up and down, like wavelengths of light and sun and sound. They also are periodic. Our sun, the way it's periodic, right? How we see the sun and the moon, it's periodic over a 24-hour period. So those are cycles as well. So a function f that repeats its values at irregular intervals is called periodic. Okay, and the period that we have, it says for any periodic function, the length of the shortest interval over which the function repeats itself is known as the period p. Okay, so the basic sine function is x plus 2 pi, meaning its period is 2 pi. It goes through its full circle between 0 and 2 pi. Cosine is the same way. The function is said to go through one cycle between every pair of repetitions. Okay, the domain of sine and cosine are all real numbers. The range of sine and cosine are -1 to 1 unless they've been shifted. So we're going to look at some transformations today, just like we did transformations earlier in the semester with our quadratic function. We did some with our exponential function. And so now we're going to do them again with our trig functions here. The other thing we're going to talk about is our amplitude. So our amplitude is the highest point, the distance from the middle to the highest point. So the function sine and cosine oscillate between a -1 and 1, and so the amplitude is 1. So it's basically its average between the highest and lowest points. Okay. Okay. They also talk about sine being an odd function because the sine of a -x is equal to a negative of the sine of x. And then the cosine is an even function. because the cosine of a negative x is equal to the cosine of x. Okay, so I'm going to go ahead and show you in Desmos. I'd like to go through and do some of the problems right in Desmos. And this is what I'm expecting for any of the problems that I assign for this lesson through 42, where it says graph. Just show me the graph in Desmos, just kind of like I have here, where you're labeling your graph and then you're showing your graph. So I'm just going to do the base cosine graph here in red. You can see if you click on the graph, it will show you it starts at 0, 1, and then the next spot you can click on, it shows you at pi over 2, it's 0, and then at pi, it's a -1. So we can kind of see the base graph of cosine of x. Then number 9 says, use vertical translations to graph at least 2 periods of the following function. So f of x, and this time is cosine x plus 3. So this translation is a +3. You're going to go through the regular cosine of x, and then you're going to add 3. So when I click on this graph here, you can see it's shifted up 3. Now I'm going to look at number 11. I'm going to just throw in number 11 here, because it's nice to see another cosine. And it says, number 11 says the cosine of x minus 1/2. So you can see that one is shifted down 1/2. So it starts at 0.5. Let me turn those off. Okay. Number 13 says use horizontal translations to graph at least 2 periods of the following functions. So 13 is the cosine of x minus pi over 4. So you can see here it's periods at pi over 4, and it is, I'm going to turn on its graph. There it is. So it's just been shifted to the right, pi over 4. So if we click on the red, the regular cosine, there it is at 0, 1. And now I can click on its height at pi over 4. So that it's shifted where its maximum originally is at 1. Now its maximum of 1 happens at pi over 4. Okay, I'm going to turn those both off right now. Okay, so 17 through 20 says use vertical stretches and compressions to graph at least 2 periods. So a vertical stretch or compression is when you are multiplying outside of the function. So this is number 17 here. And 17 is asking us to graph a -2. So we're multiplying by 2 of the sine of x. And you can see it's flipped over, because usually I'm going to graph just the base graph of y equals sine of x. Okay, so in green, I'm sorry, in purple is my regular sine of x. And so you can see it starts at 0, its maximum is at 1, and that happens at pi over 2. But in green here, it's saying, take that, the negative means it is flipped over the x-axis, and the 2 means it's a stretch. So we're stretching it by 2. So we're taking the output and multiplying by 2. Pretty cool. Now, one with a compression would be where that a outside of the sign. So I'm going to show you again how this is written if we go to the book here. So notice here at the beginning of the lesson, they define when they have a good definition written out. Function. I guess I can just show you my paper, because I have them written out. This is from page 460. So A times the sine of B. So this is where our vertical stretch will happen. So the vertical shifting will happen there. And and if there is any horizontal shifting, that will be happening inside the function. So the B. So this is the vertical shifting will be the A. And you can see that the one on number 17 is a negative. So 17 is -2 sine X. So the 2 is a vertical stretch. And the negative means that we are flipped over the horizontal, sorry, we're reflected over the x-axis. So that negative is the reflection over x-axis. And page 460 does a nice job of explaining. So if you go to page 460 at the bottom here, it kind of goes through all that we learned back in earlier chapters on the horizontal stretching, horizontal compression. Those are going to be your B value. So the B is going to be multiplied inside the sine function or inside the cosine function. And then the vertical stretch or compression is going to be the A, which would be outside of the function. And then we have the reflection. If A is negative, then it's a reflection across the x-axis. And then we also have our horizontal shift, which would be C, moving left and right, and then our vertical shift, which is D, which is up and down. And that's going to be added or subtracted afterward. Okay. So let's go back to, so then I also wanted to look at number, not 17, but number 19. So 19 is the g of x function, which is 3/2 cosine x. So this is a vertical compression. Meaning everything is a little more spread out now. Instead of like really sharply going up and down like the vertical stretch up here with the 2, it's going to be more spread out like a really slow wave at the beach just on a relaxing day. And that's because A is a fraction. It's 3/2, so it is bigger than 1, so it's still going to be a stretch, but it's going to be slower than this 2. Let's see. So if we looked at 20, number 20, 20 has, it's a -1/2, and so because that's between 0, -1 and 1 there, then it's going to be more relaxed than the normal function. Let's put that in. I'm going to help you out on your assignment. So I'm going to put in y equals, and then we're going to have a -1/2 of x. So you can see the purple is our regular sine. Our green is our -2. It's really oscillating up and down. And the black is the compression, where it's just a little bit slower, like I said, on a really nice relaxing day at the beach. Okay. So let's look at 21. It says use horizontal stretches and compressions to graph at least 2 periods. So let's look at number 21. So number 21 is y equals 3/2 oops, no, sine 3x. Okay, so you can see, I'm going to go up and turn on just a regular sine function again. So a regular sine function is in purple, and then look at the sine of 3x. It's really, what the 3 does is it makes you go through your period, the period of your function that much quicker. And then let me show you a good one that would be a compression. So let's do 23. Just do one. So I'm going to turn off the sine 3. Okay, so now our original purple, I'm going to change this color here. Change the green so we can see it better. Okay, so there's purple is our regular sine function, and the green is this compressed, and it's really making the waves stretch out and moves much slower. Okay, so let's look at let's get down to 29. So 29 has a vertical compression on the outside, and then it's 1/2 the sine of 2x minus pi. So remember, you have to go down to your little menu here in Desmos to find pi. And put it right there. Okay, now I'm going to turn off my other graphs here because I don't need that green one. And I'm just going to let 29, you can see, be up against the regular sine function in the purple. So number 29 is in red, and it's very short and quick. And let's see what 33 looks like. Turn off my sine function here. $33 is a reflection because it's negative cosine of 2 pi x parentheses plus 2. So it's a vertical shift up. Wow. So that's very like, reminds me of like a bunny, like hopping up and down, up and down, up and down. And it's shifted vertically up, and it has been reflected over the x-axis. And so, interesting. Very cool. Okay. Let's look at number okay, so let's look at number 37. It's asking us to graph the pair of functions on the same set of axes. As are the graphs of f and g identical or not? So 37 is, we're going to graph y equals sine of 3x, and then y equals 3 sine of x. Okay, I'm going to go up and I got to turn off my number 33 for a minute. They're definitely not identical functions. Sine of 3x is this black one here. It's just forcing our period to get quicker. And then this red one is really stretching it. out. So 37 is no. Mhm. Okay, so that's one there. Okay, so question, let's move to some of the ones down below on 45. Looks like a great one to give us an experience here. So 43 through 46 are asking us, oops, let's just go to the book 43 and 45, and then I'll share my paper. There we are. It says for each graph, find its corresponding expression of the form. So these are for sure sine graphs, and we had to see how they could be written. Sine of x minus a plus b. So 45. So 45, let's just look at it for a minute. So sine usually starts at 0 and then goes up to 1. And this is not starting at 0, but it's going down. So I think that this is going to be a reflection. I think it's going to be a reflection of some sort. And then let's just see, because it's not going up, it's going down, it's a reflection, and it usually starts at 0, but now it's at 1. So if it's a reflection, then this might be an addition of 1. So if it was an addition of 1 that was reflected, it would be up at 1. So this is a subtraction of 1 at the end. We're thinking, this is me thinking out loud of what's going on here. So that's kind of how you're going to walk through these, is you're just going to think about them as and so because they want it in this particular format, sine right here, because they want where the mouse is, this particular format of sine of x minus a plus b, then we can't have a reflection. So there's not a negative out front. So how can we look and see where does sine usually goes 0 and goes up, right? So where does it start going up? It's at 0 or at its minimum, maybe right here at pi. And then we go, because at pi, it's at a -1. So let's say if we had subtracted 1, if it was a shift down, then that's where it would be at 0. So it looks like it's shifted over pi. And it's shifted to the right. It looks like it's shifted to the right pi. So because this is x minus a, if it's shifted to the right, it's going to look like x plus a. Let's see here. So we said it's not going to be a reflection, so this will be plus the sine of x plus pi minus 1. Because it says the restrictions are, they wanted sine of x minus a, where a and b can be any number, and then plus a b. A and b can be any number. So let's see if we put this into Desmos, if it looks like our graph. That's how you can check to see if you came up with the right thing. So this is going to be 45. So we think it's y equals sine of x plus, let me turn off my other two up here. X plus pi. Okay, there's, it's definitely going down like that. And then if we go over here and say subtract 1, does it shift it down? That's quick. There's pi over 2, so -2, and 3 pi over 2 is at 0. Okay. So where is it at pi? So right here. Next to 3.14, it's at about -1, if I can get it there. Okay. Okay. The next one, and these are tricky. Let's do 47. 47 is asking us to find one that looks like the graph that they have there in the book. Let's go to the book. So 47 is starting at 0 and it's going up. So sine starts at 0, but it's going up to 3 at pi over 4. And at pi over 2, it's back at 0. But they say we can, this time we can use a times the sine of bx or a times the cosine of bx. Okay, so there's no vertical shift. So it could be a vertical stretch or compression, which is the A, or a horizontal stretch or compression, which is the B. So it looks like it could be sine multiplied by 3, like a stretch of 3, except for it's happening at pi over 4. So it's definitely happening quicker. So let's just play around with this. So if we do y equals 3 times the sine of x at pi over 2, it's at 3. But we need it to be at pi at, let's see what it was, to be at 3 at pi over 4. So how can we do that? Maybe if we, let's see if we double this, would that do it? So pi over 4 is 3. Ooh, that might be right. And then it looks like at pi over 2, it's 0. Let's see where it's 0. Pi over 2. And then when it's down here, -3, oh, let's close our. So down here, -3 is 3 pi over 4. That's what it looks like. It looks like we created number 47. 3 times the sine of 2x. So you're just kind of playing around with them to see what you can do to make it work out to match your graph. Good job. Okay, what if we were to do, oops, no. What if we were to do number 50 here? Number 50. Y equals, it's number 50 in the book. Number 50, I thought we could try because it looks like it might be a cosine because it starts at 5 and cosine starts at 1 and then it goes down. So a cosine starts at 1. It could be 5 times cosine, but it's happening instead of being, so at pi over 2, it's 0. This has it being 1 or negative 5 at pi over 2. So let's first multiply by 5. Let's do 5 cosine. 5 cosine x. Oh, let's turn off my sine function here. Okay, so we have the 5, but it's 0 at pi over 2. And the graph says that we need to be, for 50, we need to be 0 at pi over 4. So I wonder if we do times, make this a 2x. Let's see. So we're still at 5 at 0, and then we're 0 at pi over 4. Is that what it wanted? Oh, no. Yeah, 50, we want to be 0 at pi over 4, and then at pi over 2 to be negative 5. See what it says. Yep, we did it for number 50. Okay, so let's move on to problems 55 through 60. So I'm going to do a couple of these because 55 through 60 says match the given set of properties with the appropriate functions. And so we have 6 functions to choose from. And so 55 through 60 is going to be one of A through H. So I say we do number 55. And 55 says amplitude is 2. So the amplitude is the absolute value of your A. So it could be A or C or D. But if it's C or D, it would be a reflection because of the negative. So let's see. It's got a vertical shift of 2 units downward. So a vertical shift would be a subtracting 2 at the end. So it looks like A and C are still in the running because D is a negative 3. It's a 3 shift down. So, okay, so far for number 55, it could be A or C. A horizontal shift pi over 4 units to the right. And the period is pi. Okay, so shifted 2 units to the right, pi over 4. Amplitude of 2. It's a vertical shift of 2 down. And a horizontal shift of pi over 4 to the right. Okay. And the period is pi. Okay. Let's see. So I think it's going to be C. Okay, because the shift to the right is going to be, so let me just write down what I think it is for 55, and I'll show you on my paper my explanation. So I think it's C, h of x equals a -2 sine of 2x minus pi over 2 minus 2. Okay. So I'm going to show you my paper. Says amplitude of 2. That would be this, the absolute value of A. The absolute value of -2 is equal to 2. So that satisfies that. And the shift for this says it's a shift of pi over 4 to the right. And none of these look like it's a pi over 4 on this shifting to the right. However, you have to divide by 2 because of the 2x. So this right here is going to be your shift to the right. So this is 2x minus pi over 2. If you set it equal to 0, this becomes 2x equals pi over 2. And then if you divide by 2, it's x equals pi over 4. And so basically you're starting at pi over 4. So you're shifted over to the right, pi over 4. So that would make that. And then this would be the 2 downward shift. And then the period, your period is equal to 2 pi over b. So let's write that, 2 pi over b. And so if we have 2 pi over b, b is this 2, then our period is equal to pi, and that's what they describe. So 55 is definitely letter C. So C has been used. Okay, I'm going to do one more. How about we do 57? So 57 says a vertical shift of 2. So we're going to have the absolute value. And so we know C's out. So we have A and D are good still. And then it says it's 2 units downward. So it looks like only A could be that between A and D, but let's just look at everything else. So horizontal shift is 2 pi over 3. So if we set this 3/2 x plus pi equal to 0, you do get a negative, you do get 2 pi over 3 to the left because it's plus pi. And then your period is 2 pi over b. So 2 pi over 2/3 is equal to 4 pi over 3. So I believe it's A. So let's just write it. H of x equals 2 cosine of 3/2 x plus pi minus 2. So let's look at the period and just validate that. The period is 2 pi over b. That is b. So that would be 2 pi over 3/2 is the same as 2 pi times 2/3. So that is 4 pi over 3, which is what they asked for. No, it was 2 pi over 3. Yeah, 4 pi over 3 is the period. Horizontal shift is 2 pi over 3. So horizontal shift is 3/2 x plus pi equals 0 and solve for x. That's how you can find that. So we're going to have 3 halves x equals a negative pi. And then a negative pi times the reciprocal of 2/3. So x equals a negative 2 pi over 3. Okay. And the shift is considered 2 pi over 3, but the negative is the left. So we are correct. It's A. I believe that I assigned you 56, 58, and 60. So that'll be fun to work through those. Okay, let's do some story problems. Those are the real life ones that we have to learn how to do anyway. So let's look at maybe 61. So 61. Says it's a simple harmonic motion. The position of a D of a black attached to a spring is given by the formula D. D equals 7 cosine of pi over 2t, where t is in seconds. Find D when t equals 1/2 and when t equals 4. So we're going to put in 1/2 and 4. So simple harmonic motion. The position D of a black attached to a string. Okay. So 61 here. We have D equals 7 cosine pi over 2t. So when t equals 1/2 and when t equals 4. So we want to find the position. I'm going to make a note so you can go back and check these out. So number 61 is the function 7 cosine. Y equals 7 cosine of pi over 2x, I believe, or t. Oh, extra mathematics back here. Okay, there it is. And so they want us to do when x is, or t is 1/2. So 1/2. So 4.95. D is 4.95. And then when t is 4, it's 7 is the position. Okay, let's look at 65, some electricity. So 65 says the voltage of here. So they're giving us a function It says the voltage in an electrical circuit is given by the function 3 times the sine of t minus pi over 2. What is the smallest non-negative value of t at which the voltage is equal to 0? So I need pi over 2. Okay, so I'm going to turn off my other graph here. And so it says for 65, what is the smallest non-negative value of t at which the voltage is equal to 0? So it's equal to 0 right here at pi over 6. That's the smallest one. It doesn't equal 0 again until pi over 2. So 65 must be pi over 6. Okay. And let's look at 67. So 67 says, the form of a sound wave is given by the function f of x equals 25 sine of 4x plus pi okay, I'm going to turn off this red one. Wow, this is really jumping up and down. Look at that picture. Wow, that's crazy. Okay, it says find the amplitude, period, and frequency. So the amplitude, okay, so I'm going to write this down on my paper. So it's, the function is f of x 25 sine of 4x plus pi. And they want the amplitude and the period and the frequency. Okay, so let's go back to my paper here. The amplitude is always the absolute value of A. So that's 25. And the period is always 2 pi over B. And there's B, it's 4. So that's going to be 2 pi over 4 is going to reduce to pi over 2. And then the frequency is, we're looking at the frequency, it says, of a sine function, it's in this story. The frequency of a sine function is given by 1 over p, where p is the period. So it's given by 1 over p. And so 1 over the period is 1 over pi over 2. So the reciprocal, which would be 2 over pi. Ooh, we learned a lot today on all those graphing. So catch me back for 5.6. It's going to be graphing of all the other trig functions. So we're going to learn about tangent and cotangent and secant and cosecant and the graphing. And then some shifting and just like what are their basic graphs? Just so we can kind of get familiar with what their basic graphs look like. So catch me back for that.